Okay, so cool. Welcome everyone. So we are recording this call. We're experimenting with a couple of recording situations to just see if at least one of them works. So yeah, welcome. This is like a massively overwhelming response, and I basically had no idea that there was like this much interest in a cryptography course. But basically, like the idea for this course is more or less the available resources for people that I think are interested in cryptography and would like to sort of understand cryptography as it's most commonly implemented right now are either non-existent or a bit out of date. So the book that we're actually using is kind of a symbol of that in that so the book is like from 12 years ago at this point. And since then, like of course like Rust as a programming language is kind of like swept a lot of cryptography off its feet, and basically most cryptography now, at least in cryptocurrency world, is written in Rust. And besides that, there have been a lot of developments in fields like zero knowledge cryptography, multi-party computation, fully homomorphic encryption, and some other stuff too. So like basically the available resources for people I think starting in cryptography today are kind of not that good, and they're especially not that good if you aren't at one of like a couple of schools around the world that really specializes in some of this stuff. And in particular, like there's been an increasingly obvious need for like what would a better cryptography engineering education look like, both for people that were just sort of casually interested, who would like to sort of like dip their toes into what it sort of looks like for cryptography engineers to do their stuff. And those folks might like to be, or might be curious on like what it actually means to choose like a good cryptography API and like how this sort of like development of the field moves and what are the sort of foundations of the field. I think that that's a sort of important need, but the other need that we're trying to address, I think mostly, is the sort of need for just an all-around better sort of like approach to how does someone who is interested in cryptography come to the available resources in the Rust programming language, which you're probably going to want to be working in, and say, yes, I know how to use the Rust programming language to actually like implement this encryption scheme or this ZK scheme. And so this is a little bit different from the API sort of caller. So I think there's a lot of sort of like, work to be done for both of these sorts of like groups of developers. But hopefully we're going to address at least most, or we're going to try to address those needs for developers that are interested in how they would use Rust to do cryptography, since we see that need as basically not being currently met. So yeah, I'm Thor, or Cryptograthor. So I have the Natterer that you have been asking questions for the last week or so in the Discord. And I'd like to, or I guess I'll introduce myself. I've been doing cryptography engineering for a couple of years. For the last year, I was working on a threshold signature scheme for a project called Entropy, which was a pretty neat project. But I kind of became increasingly aware that I really felt like the thing that I wanted to do was sort of like fix the problem that I saw. That was basically that there were a lot of people that were kind of like me in my field that taught themselves and had a bunch of like sort of experience kind of learning from books or learning from APIs, but ultimately like the sort of learning process for basically all of my peers has been largely one of isolation, and that ultimately like almost everyone in my field, it seems like, is a self-taught developer type and doesn't actually know where the holes in their learning are. So I was kind of feeling very frustrated with that while I was working as a cryptography engineer. And I thought, well, what would a better approach to cryptography engineering education look like? Since everyone here is self-taught, like what would a better resource for people who, like to teach themselves stuff look like? And so that's sort of how we got to the Uncloak idea. It's sort of a fusion of two ideas. One is this like in-person study group, which we're going to, or I guess we're doing now. And the other is like a static resource that lives at the uncloak.org website, which is a sort of experimental wiki. And to just sort of like give a quick natter about what that experimental wiki is about, my basic premise on like how wikis succeed is that they are community contributed and they're open, which means that they have the capacity to actually capture the knowledge of the crowd, which is really important. But they don't do a very good job of capturing how concepts sit in context to one another. So when I think of technical content, I tend to think of it as something that is represented in this sort of like dependency graph of ideas that build on each other in sort of recursive ways. And so like my best shake at like how would you actually create a sort of long-lasting resource on any particularly technical topic, well, you'd want to have a vector to capture that dependency graph structure. And so that's why we're using the Uncloak site is built with this sort of interactive graph. And you can find that site at uncloak.org. It's currently in a sort of state of disarray. I stayed up a bit late last night rearranging some stuff, but I didn't quite finish. But there will be a contributor guide posted later today if contributing to that wiki is something of interest to you. So to sort of wrap that natter up, welcome everyone to the Cryptography Engineering Study Group. We're hoping that you'll learn some cryptography and learn some Rust. This study group is specifically here for, I think, like the need that a lot of people in cryptography basically are self-taught. So the thing that we're trying to do is make it easier for everyone who's sort of interested in cryptography to understand the field. And okay, so this is the background noise. All right. Yeah. So yeah, the study group is here to make it easier to learn cryptography engineering, especially since there isn't very much in the way of resources at the moment for Rust-based cryptography resources. And finally, there's the Uncloak graph, which is where we're going to try to create a long-lasting resource for cryptography self-educators and potentially also in the future researchers. But that's sort of another story. So yeah, with that wrapped up, I'd like to introduce Chloe. So if Chloe would unmute herself and introduce herself, that'd be cool. Chloe?
Hey, sorry, I'm back. My Discord client does seem to keep crashing and shutting down. Maybe because such an active group. Hopefully, I can be heard though.
Yeah, I can hear you loud and clear. Sorry to hear about the technical difficulties.
No worries. It happens.
All right. We might be having a
Crash.
technical... Oh, you're back.
Yeah, it was instant that time. But I'll try and get an intro in at least. Hey everyone, I'm Chloe here, Chloe the dev. Been involved in the, I guess, blockchain space for a number of years now. But I guess a few years ago, got really interested in.
Okay. So it looks like Chloe's connection is struggling right now. Chloe, would you maybe instead post a self-description in the chat, since that might be a little bit more gentle on your internet connection? And I'll just sort of continue along here. So yeah, Chloe is going to be the co-host of this study group. Yeah, so there's been a question in the chat. Any thoughts on the book on Introduction to Mathematical Cryptography? I think Introduction to Mathematical Cryptography is a great sort of mathematical introduction. I think that the first two chapters in particular are a strong introduction to asymmetric key cryptography. The book focuses primarily on asymmetric key cryptography. And I think the book sort of starts ramping up in difficulty around chapter 5 when we start hitting elliptic curves. So I do recommend it as a supplemental resource, in particular if you're I think it's a sort of upper undergraduate level sort of like mathematical text. On David Wong's Real World Cryptography, I think the book feels less authoritative. I think the book covers slightly different content. We will be using the book as a sort of supplemental resource to inform some of the topic material that we cover in this course. But I do end up feeling that the cryptography engineering textbook that we're using is a little bit more authoritative than David Wong's book. Yeah, okay. I think that's the question backlog. The audience is invited to dump questions in the chat, and I'll try to address them like I just did in a reasonable time. So yeah, let's continue down the listy list of stuff. So onto structure. So the basic structure of this course, we want to run the course for 4 months. 4 months so that the course doesn't sort of drag on and sort of like decay as like we kind of feel we cover or fail to cover certain topics. Um, yeah, just in a nutshell, I think 4 months is a reasonable length for a course. You can sort of use the course in several different ways. So a sort of minimum time commitment to the course is that you like hang out in the Discord server, right? So like if you hang out in the Discord server and you have like a cryptography question and you didn't do the reading, like that's totally fine. I'm hearing some background noise on someone who. Okay. Yeah, so you can hang out in the Discord and ask your questions on cryptography without even reading the book, and that's totally fine. The next level up would be like 1 hour commitment a week. You hang out in the Discord and occasionally meet this group, or you read the book. You do like the sort of like assigned weekly reading homework, or maybe you skim over the weekly homework. And if something is unclear, you're welcome to ask questions. That's totally fine too. The sort of addressed level of what I think the main audience of this study group is basically we want to encourage people to engage with cryptography engineering. And to that end, we are going to be assigning weekly exercises. Some of them are going to be from the book. Some of them are going to be our own exercises, sort of gesturing in directions that we think that the book could be extended. In particular, we'll be focusing on having at least one implementation exercise a week, often with some other sort of adjacent questions. So like, for instance, this week, one of the assigned homework questions is to get comfortable with researching where a standard specification for like RSA encryption would be. So our general goal with this is going to be help you sort of understand how a cryptography engineer might think about how they would solve a certain problem, like implementing like RSA encryption or finding libraries that they need. I'm seeing a question in the chat from Evil Morty that Discord is failing. Can someone give me a signal if they can hear this? Evil Morty just posted a great troll. Okay. Poll. Evil Morty just posted a great troll. You're welcome to post your trolls in the channel too. I like trolls. That's good. Okay, so I'm getting a lot of stay on Discord reactions to Evil Morty's poll. Thanks, Evil Morty. Doing a great service for the country. And besides Chloe not being able to join, this Discord is working. Okay, yeah. So it does seem like, yeah. So in regards to the muting, I think the sort of conclusion of this particular experiment is stage channels, like Technicality just suggested. It would be too much of a pain in the ass to switch to it mid-session, but we'll do that next week. On to, yeah, so the structure, basically, we're going to have weekly reading homework through the book. We'll follow the book mostly linearly. We'll skip a couple chapters at the end to sort of cover some adjacent topics. But the main approach of the study group is that it's slightly different from a class. Yes, there's a sort of like weekly lecture session, but I think the sort of main emphasis of a study group as opposed to like a lecture is that there's that participation and sort of communication with one another is encouraged. Especially with a course this size, it's kind of difficult for just one or two sort of like study group leaders to really answer all lecture questions. So the sort of like ongoing nature of having access to Discord means that you actually have access to this community of people that are sort of interested in the same things that you are, hopefully. So that could be really useful. I want to take a quick moment to address like what makes a question good. Good questions are specific, but good questions are not necessarily smart. Dumb but honest questions that are ones that you just didn't get. You looked for an answer for like 10 minutes, didn't find it. You looked at the text, it confused you, whatever. If it's dumb, that's fine. If it's honest, that's great. If it's something that you actually wanted to know the answer to, totally ask it in the chat. Dumb but honest questions are much more useful, I think, for both yourself and everyone else than showing off how smart you are questions. The best way to show off how smart you are is to help other people answer their questions. So that's really important. moving on to the book. There, I think, we've assigned 2 chapters of reading homework this week. Chapter 2, which is a sort of like quick bird's eye view of cryptography, and chapter 23, which is a sort of warning note about don't think you're an expert about cryptography after studying a single textbook for 4 months. Which has some sort of like interesting advice, or maybe applicable advice. But I think like maybe the book undersells the importance of auditors and oversells the importance of cryptography experts up front. I think both are important. Okay, so I'm seeing that some people are rushing ahead here and reacting to the prepped message. So I'm about to post a poll in the prepped message, or in the Discord, and I'd like everyone to react to this poll. So the poll is specifically for people who would like to attempt the exercises, and I'd like you to react to this poll if you'd like to be part of a homework study group. Now, the homework study groups are specifically for basically because there are on the order of 100 people in this chat. There will quickly grow sort of out of control the like number of like, basically if you have a small study group, it's easier for you to have a direct connection to other people in your group than if you have this massive group. Now, everyone who's reacted a rocket or a checkmark emoji, I think we want to upper limit the groups to about 5. So the rockets are now hovering around 30. So I want a bunch of people to unreact to those rockets, and move to smaller groups and do a different emoji. The people who are creating new emojis, the settlers, the frontier shapers, I want to applaud you. You've done a great service. Yeah, we got a crab. Finally, we got a crab. Okay. And the rocket ship has dropped to 13. This is great. I feel listened to, but at the same time, we might need to find a new crab because I think the crab has just eaten everything. Yeah, the crab is now winning. React Elite Squad. Yeah, definitely. So I'm going to let that sort itself out. Basically, the deal here is that I won't be managing your groups for you. You can't have add more reactions. Fascinating. Wow. Okay, that's really interesting. I didn't know that you could do that. We did it. Okay, we did it. Second message. Okay, so react to the second message if you hit the cap for the first message. And try to make sure that the groups are no more than 5. If you guys get up to 6, that seems like it's kind of pushing the upper number, but there is also new frontier for new emojis on this second message. Yeah, okay. So this is a really interesting experiment to watch play out in real time. Yeah, it's kind of fun. Okay. So the checkmark still has 12 people in it, and the upper crab still has 11 people in it. So if you guys would pour out to some other group, that'd be killer. Everyone who's doing the thing, well done. Can we expand on the suggested prereqs of the course, math specifically? Yeah, we can. So this course will introduce some mathematics, but it generally won't be as math heavy as the, I think, usual treatment of cryptography. Now, if you want to continue in cryptography engineering, basically math is unavoidable, and it should be sort of clear that it's sort of on you to like go ahead and like take it on yourself to learn some math so that you can sort of follow along with papers and understand kind of what's going on. But this course is more going to be targeting the sort of like, what does it mean to actually, once you have an algorithm in hand, how do you go ahead and sort of take that algorithm and implement it, right? And so like, of course, like if you understand intuitively how the protocol works, you're going to be less likely to have random sort of obvious mathematical bugs in your algorithm implementation. But you should reasonably be able to sort of work with cryptography up to a certain point without necessarily having to understand the entire underlying proof of like a particular algorithm that you're using. And Chloe has got her audio working. Cool. Um, yeah. So the study group experiment that is up above in those first two messages, I'd like you guys to go ahead and create groups with one another. I won't manage that for you. That's on you guys. So go ahead and look at the other people in your group. Create a personal sort of direct message group with those other people in your group. And those will be your exercise study buddies. There'll be another sort of rebalancing of the study group attempt, I think, in a week or two, especially since I expect the course to just decay naturally because a lot of people who show up on the first week can't always show up on the second or third week, so decay happens. But I'm looking forward to seeing how the sort of like small study group, exercise group project goes. Hopefully it'll be useful to you since I think posting to a smaller group of people who are a little bit more closed and sort of immediately accessible is sometimes very useful. Yeah, how are we doing? Okay, so moving on to other things. Okay, yeah. So I guess like I'll address the Rust and mathematical requirements. So the exercises for this week contain a couple of implementation questions that are maybe representative of what I think is sort of like the base level of like what is reasonable, and it's probably not going to get much easier from there. So there are questions about how to benchmark an algorithm, right? So like I think question 3 under general is benchmarking an algorithm from question 2 using one of 2 different benchmarking suites in Rust. Benchmarking is pretty much like your ground truth for like, is it efficient? Well, you find this out by benchmarking stuff. And like this is the kind of thing that if you can read an API reference or a library reference, the documentation that tells you how to use the benchmarking crate, then yeah, you've kind of got like at least the minimum level of sort of expertise covered. Slightly up from there is the one of the I think the third to last question. No, the fourth to last question is implementing the Vigneri cipher. So the Vigneri cipher is a pretty simple cipher. It's a historical cipher that basically was undefeated for probably on the order of hundreds, if not 1,000 years. And it's also very simple. So that's like about as simple as I think like implementing cryptography gets. And cryptography, it's basically not simple in any direction. It's a field that I think is going to okay, so someone started a thread. That's neat. Yeah, so cryptography by no means is simple, right? So the programming languages that we choose to implement cryptography, in particular Rust, we choose these languages specifically because they make it easier to express the full complexity of cryptography in a way that is secure, basically. So the sort of like Rust programming whole pitch is that if there are bugs in your software, then like Rust should at least prevent you from making the obvious ones, all of the ones that the compiler can analyze. And Rust is like very powerful at that. It does quite well, and it's very efficient and sort of has a lot of features that I think are. Oh, I love this. People are finding each other in India and the west coast of the United States and Lisbon. That's cool. Okay. Back to okay, so I'm looking back, a bunch of messages popped up. Okay, so so I got added to. Will this course be helpful for someone programming in zk-L2 directly, or will it only be theoretical about cryptography? If you're working with Rust and you're working with zero knowledge or layer 2, then it could potentially be useful, in particular since it'll inform about what sort of other cryptography tools might be useful for you. I think there's a lot of sort of emphasis in ZK that you can just learn ZK and not the rest of cryptography, which I think is like to some extent true, but it's also certainly helpful to have context about like where ZK has foundations, because the rest of cryptography is used pretty thoroughly throughout ZK. Like zero knowledge stuff uses commitment schemes, encryption schemes, hash functions, and a bunch of other stuff that's specific to zero knowledge, and particular complexity theory comes up a lot. But do you have to understand like foundational cryptography to understand ZK stuff? The answer is like, no, not really, especially if you're just using ZK APIs. But will there be any discussions of security and audits related to smart contracts? So I actually hadn't much considered security and audits related to smart contracts, but I had scheduled that every 5 weeks that there would be an opportunity for group members to submit a piece of their code no longer than, say, 300 lines of code for review by either myself or one of the volunteer auditors. So discussions of security audits related to smart contracts. If I could find some smart contract examples that I think specifically demonstrated concepts in cryptography, I think that that would be something that I'd be interested in doing. I haven't really looked very far. And I was considering having like a week basically dedicated to attacks. But I guess I would have to look into that more. So I basically don't have a complete answer to you. I hadn't considered smart contract as a primary area of interest, but it seems actually as like it could probably be pretty practical for a lot of people in this group, so I'll look into it. Going back down. Oh, you guys chatted a lot. This is great. Practical ask. Okay. Yeah, I don't see any other questions in the current run of threads. So yeah, before I dive into some quick notes on chapter 1 of the book, I want to ask if anyone has questions about like the first part of the natter. Oh gosh. Okay. So, questions in 3, questions in 2. A natter is where you just talk for a long time, like I've been doing. It's where you feel the stream of consciousness flow out of your mouth and just like let it go for the next 15 minutes at a time. Spelled Natter.
I love your nattering, by the way. So.
Thank you. Yeah, much appreciated. Okay, so I think the thing to do here is going to be to... Oh, I hear someone speaking, or making noise, as it were. Is there a question before... Where's Natter Dabbit? Okay, I don't know where Natter Dabbit is, unfortunately. Okay, so yeah, covering the first chapter in the book. The first chapter in the cryptography engineering book is pretty straightforward. It's kind of a fluff chapter, if I'm perfectly honest. It's mostly just an opportunity for, I think, the authors to sort of like wax poetically about cryptography being the art and science of encryption and many other things. But the major things to take out of the first chapter, I think, are really about like this premise of sort of paranoia as a practical skill. And sort of an understanding of what's worth being paranoid about and how to sort of be paranoid in a useful direction. So like the example that they give in the first chapter of an office building where they put locks on the doors, but a burglar can just like, jump up through the ceiling and jump around the door, really demonstrates this like weakest link property. So like, I think a very useful thing in general, when this is not just true for cryptographers, but just in general for software developers, is this question of how do I be best paranoid for the thing that I haven't considered, right? How do I find the weakest link that there's going to be a way to bust through sort of like my assumptions here? So like a lot of the time, like I think like when I go to develop a piece of software, one of the things that I know to be true is that the thing that I'm most likely to lose the most time to is like debugging random bullshit, right? And debugging random bullshit is good insofar as like when you're done with it, you think the thing works. But in fact, like if you're debugging random bullshit, there's probably more failures of like random bugs that you just haven't found yet, or at least that's oftentimes true. So like the whole choice to use Rust as a programming language is like a reduction of this sort of attack surface of random bullshit bugs that you could potentially run into when you run the when you do software. To answer, can I screen share to be on the same page? I'm a little bit afraid of screen sharing at the risk of like knocking this entire like tower of Discord twigs over. But yeah, I'm going to look at ways to do this better in the next week. So not today, but maybe soon. So yeah, so like basically the point that I want to emphasize is a security system is only as strong as its weakest link. The piece of advice that I think this relates to is that ultimately, like if you are capable of being paranoid about ways that you yourself are likely to miss a weak link as a software engineer, that's basically the most important thing, I think, if you are like developing software that's particularly at risk. And this is applicable for anywhere from like smart contract engineers all the way up to like cryptography engineers and all the way back. And I guess the way that I usually do that is I prefer to basically plan and prototype my software and like twiddle with my sort of prototype idea for a while with the whiteboard or whatever. Do pseudocodey things. And this is especially useful for like developing an idea out and sort of ways that, okay, when then forums for question? Forums for question seems good. Yeah, it looks like there is a way to do forum for question. So I think that's going to be next. So I would encourage the doers of the exercise to consider the sort of lessons of being paranoid about ways that you might improve your design process and reduce your capacity to have bugs. And another major sort of element of this is that a lot of the time when you're developing something, there are things that you don't know, and it's kind of hard to map. But there are things that you do know, and that is the sort of like, I think, game that we play as software engineers is that we try to understand as best as we can the things that we don't know, and black box the things that we do know that we don't know. But this can be very difficult. So I think a sort of like good mental model of like how you understand a system and things that you don't understand is maybe the second thing that I would bring up with like how to be paranoid about security in the correct directions. Well, you should state your assumptions about your black boxes, because your assumptions, once they're explicitly stated, you can actually discuss them with other people. And so that was sort of explicit statement about things that live inside of your black box, like cryptography lives inside of a black box for many developers, are very useful. Kind of continuing on, your black boxes tend to have assumptions that we make about them. And sometimes our assumptions are rendered untrue. And sort of the maybe last element of like this particular matter about paranoia and the weakest link is that if there is a way to layer security on top of each other, that's referred to as defense in depth. So that even if an attacker were able to compromise one of your incorrect assumptions, that all of your assumptions would live in series to one another rather than in parallel. So an attacker would have to break several of your assumptions in sequence as opposed to any one of your many assumptions. That's preferable for any piece of software that is security sensitive. Okay, so I tried to create this forum here. Can you guys see that? Yeah.
Yes, I can see this wonderful forum. Looks beautiful.
Yep.
Extravagant.
Okay. Yeah, I can post a testy test. That seems to work.
And I see your nice test post as well. So
yeah. Okay. So yeah, going forward, ask questions in the study group forum so that we can kind of have a better sort of vector for answering them. Okay. There have been more questions since the last look. Will this course briefly cover how quantum computing affects crypto algorithms in use? Yeah, so I had been considering having quantum computing being one of the special topics that we cover in the last 4 weeks or so of the course. Since I think that the book is a sort of good start to understanding cryptography engineering, but like I suppose I've mentioned now at length, the book is a little bit older, so it's about 12 years old. I think quantum computing is a sort of very interesting sort of like question that a lot of people have. Ultimately, I think the sort of question of what do quantum computing algorithms do? Well, they're basically, and this is my hot take, so take this with a grain of salt. Quantum computing looks to be at least 20 years away in any significant way. So the question is, given that I think that quantum computing is like more than 50% likely to not arrive in less than 20 years, and maybe less than 10% likely to arrive in like 10, like what are the things that we would have to think about when we were designing crypto algorithms? So like the question I think mainly boils down to, well, if I could impersonate someone using their private key from 20 years ago today, but their private key rotates every, say, year, then I only have like an invalid private key. But if I could break their encryption system, basically from 20 years ago, something that they said 20 years ago might still be sensitive, it might not be. There are some types of things that are very sensitive and some types of things that are very much not. So there's a different set of there's a different class of problems that you have to consider when you're sort of thinking about quantum crypto. And the cost of switching to a quantum crypto algorithm over a sort of current algorithm is usually roughly a 30x decrease in performance. So there's very much like a non-trivial sort of performance cost that you pay for switching over to post-quantum algorithms. And general forum, course briefly cover. Port said that he can cover this in the security section. Cool. Is there any repo in GitHub we will use? Yes, there is a repo we will use. I haven't made it yet. But you are encouraged to use your own repo for generating your own answers to the exercises. When coding whenever you want, but the sooner the better. Preferably if it goes until like late in the evening, then you're probably doing it right, but no time is a bad time. Is the study group yet? Yes, the study group is yet. It's been 20 years away for 20 years. I assume that's referring to the quantum computing and not the study group, because I think the study group is finally here. It hasn't been 20 years away for at least the last 20 years. And 10% chance is a lot, IMO. Yeah, I'm kind of just like throwing out random ballpark numbers. But the point is taken. Blah, 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 blah. Looking forward to... Yeah. Cool. Yeah, there are exercises posted in week 1. Check out the document that I shared at the top, which I'll share again. Before sort of wrapping up in the last 15 minutes, I think I'm going to open this up to any further comments about the group. I will be working to answer any questions that you have over the course of the next week about the exercises. You're encouraged to ask questions about the exercises both in your private group and on the Discord in general, so that you can have sort of an opportunity to build a relationship with people in your little private group. And if your personal private group doesn't work, feel free to DM a mod, Chloe or I, and we can help you find another private group that works better for you. We'll probably reevaluate the private groups in about 2 weeks to see how they're going and maybe reshuffle them if that seems worth doing. Yeah, I will pin that. Beep, boop. Yeah, okay, maybe now would be a good time to just sort of address the exercises and the homework for next week. So the next week's homework is going to be reading Chapter 2 of Cryptography Engineering. And Chapter 2 is sort of a high-level overview of cryptography. We kind of cover a bunch of like the very common sort of things that you hear in a sort of like introduction to cryptography. A lot of the basic primitives, authentication, digital signatures, encryption, the difference between symmetric key encryption and asymmetric key or public key encryption, the chosen ciphertext model and the chosen plaintext model. Note that the book actually introduces two models that almost are never used anymore, which are the ciphertext only model or the known plaintext model. These were sort of more old historical models where I think cryptographers sometimes still rely on these, but realistically no encryption scheme is considered secure if it's only secure in the ciphertext only or known plaintext model. It's really only chosen plaintext or chosen ciphertext models that are sort of understood and recognized. And in CPA for the win, yes, indeed. I think the main thing to take out of the next week's reading is really going to be about trying to get a sense of like what are the primitives that are available to you at a sort of high level in cryptography, what these sort of basic concepts mean, like what does a bit security mean? Why do we say that collision attacks mean that you should double the number of bits in your key for like a hash function, for instance, or not just double the number of bits in your key to basically still have like half the number of bits of security. So if you're familiar with collision attacks, that should make sense. And yeah, I think so. The next week's reading is basically going to be this high-level overview of cryptography. I should probably assign one more exercise on collision attacks, since I think I forgot to assign something on that. But the next sort of section of reading is like also like something that you might look at is like the opportunity for many points to jump off. Because this is sort of how high-level overviews work, is that lots of different sort of like overview, lots of different sort of like rabbit holes exist in your high-level overview. So if you feel particularly inclined to go jump off and dive into a rabbit hole, you're welcome to do that, especially if you'd like to share notes that you make along your rabbit hole with the group, which I think could be super valuable. Looking back at so I will personally be posting notes both in a private GitHub or in my personal GitHub, and some of the notes will work their way back to the uncloak.org site, which currently is reasonably sparse, but is going to be growing over time. Then finally, we were going to say something about the exercises. Yeah, so about the exercises before I dive in. Okay, so yeah, I will post the answers to exercises at the end of every week. I will also post a place for you to share your attempts at the exercises soonish. And I think we better create a weekly meta thread in the forum for exercise submission. Yeah, I can do that. And I would totally open up a ZKML sort of chatter channel. So I'll get back to that in a second. Breakfast burp. Yeah, about the exercises. So the exercises each week are intended to sort of demonstrate like basically a sort of set of questions that you might actually encounter as a cryptography engineer. They should get you basically a sort of realistic understanding of like the kinds of things that you would do as a cryptography engineer. And they'll be ramping up in difficulty over time. So I think that the sort of initial set of exercises are pretty easy. When it is possible, I'll also link to particularly relevant papers. So this week's relevant extra reading paper is New Directions in Cryptography. And this paper is basically, it's kind of like the paper. The paper in the sense that basically all of sort of asymmetric cryptography kind of comes after this paper. So it's a paper by Whitfield Diffie and Martin Hellman, where they basically propose, hey, what if we did this asymmetric encryption thing? And everything that comes before this paper in 1976 is basically just a couple of sort of experiments in making symmetric encryption algorithms. But the sort of like whole array of sort of things that are interesting in cryptography emerge out of this intuition that the attacker, or sorry, that that Alice and Bob don't need to hold necessarily the same information, and that we can incorporate these elements of information theory and of complexity theory into our algorithms, thereby sort of exploiting interesting properties of one-way functions. And the sort of like race to like do interesting things with complexity theory in applications of mathematics really falls largely out of this paper. And interestingly, Diffie and Hellman actually weren't the ones to first invent asymmetric key encryption. It was actually invented by a British cryptographer about 5 years before that. And it wasn't until the 1990s that the British cryptographer could come out and declassify the fact that he had basically invented asymmetric key encryption and shared it with the CIA. And both the CIA and and I think it was GCHQ, the British organization, said, okay, so I can see that, this asymmetric key cryptography thing is like interesting, but because we are the government and it's really actually quite easy for us to distribute symmetric keys, we're not that interested in asymmetric key encryption. And so the real power of asymmetric key encryption is that it enables actors that are not already powerful to do their sort of key agreement step, having never spoken to each other. And that wasn't actually that interesting to governments because, usually governments know pretty much like whoever is going to talk to each other, they probably work for the same government, which is kind of funny, right? When you think about it, it's like the asymmetric key cryptography sort of revelation was like mostly uninteresting to groups like the NSA and the CIA because, they already kind of know each other. So they can probably pre-arrange to share symmetric keys before they do their encryption. So yeah, that paper is the assigned reading for the assigned extra reading, I should say, for this week. And one other extra assignment that's going to be sort of like a standard reoccurring extra assignment is that if you find that you have some ideas about how you might like to contribute your knowledge back to a static resource that is the Uncloak graph, is our sort of attempt at a wiki, you are invited to do so. And so with that, I think we're going to start wrapping up breakthroughs in less than 10 pages. Yep, exactly. Paper was breakthrough in less than 10 pages. Yeah, so beep, beep, boop, boop, boop. Chloe is incorrect that we're reading chapter 3 and 4 for week 2. We are reading chapter 2 and chapter 23 for week 2. So the homework may be slightly unclear as it's currently written, but the reading for this week is chapter 2 and chapter 23. So can anyone else make an announcement for reading and extra reading this week? Yeah, I don't know how to interpret that. Cool. Okay, so to wrap up, thanks everyone for joining this week. I hope you get a lot out of this course. I'm going to do my best to sort of enable you as best as I can to sort of like get the most out of like 4 months of learning cryptography. This course will be useful, I think, for hopefully a lot of people. And even if you don't intend to actually do very much cryptography engineering, I think like basically this 4-month course could be very useful to you if you intend to basically work with cryptography APIs and maybe even ZK APIs. And a bit of an alpha leak, I would like to do another study group after this that's specifically targeting zero-knowledge developers. But I think that one of the larger problems in sort of education attempts for zero-knowledge developers is they tend to skim over a lot of the foundations of cryptography. So a lot of the sort of like interesting things in zero-knowledge are only sort of interesting if you have some context on like the broader sort of picture of like what cryptography came before it. And so like I'm really hoping that you all get the most out of this sort of experiment and study group. Please share your feedback with me. You're all welcome to @ me with your particular feedback for this channel. And I think that's pretty much it for today. I'm going to wrap up now. If you want to move your small study group, your personal group, change groups, you're welcome to DM me. And finally, I'm going to try to follow up on some of the suggestions that came up in this session. And thanks everyone for joining. So I am going to peace out here in a second. So yeah, thanks everyone. Have a great weekend.
Thanks all. You're so